All right, so here we are with lesson 3 in unit 4. Warm-up problem here about Xander. He's biked 2 miles so far this week and then plans to bike an average of 6 miles a day over the next several days. So what this is asking us to do here in part A is to find the slope of the graph. So that's what we spent the last 2 days doing, finding slope. So I'm going to go ahead and draw a slope triangle here. So up and over. Now I do have to be careful because my y-axis is not counting by ones. It looks like it's counting by twos. So when I go up, I'm saying up 6, and I'm going right 1. Okay, and it does ask me where do you see this value in Xander's equation. So if my slope is 6, okay, I'm seeing that with the x in the equation, okay, because it is the rate of change. All right, and it also says that he plans to bike an average of 6 miles per day. What value does the graph touch on the y-axis? Well, it says right here it touches 2. Where do I see that in Xander's equation? I see that as the constant. Okay, so we're saying the constant is the same as what we call the y-intercept, where the line touches the y-axis. So we're going to build that out today when we talk about y equals mx plus b. This should not be new to you. Slope-intercept form is y equals mx plus b. It's a linear relationship. Okay, so the m value is always the coefficient. All right, this is the slope. Okay, it is the rate. You might also hear it called growth. Those are just a few words. The y-intercept is the b value. Okay, you might also hear it called the starting value. All right, you might hear it called the initial value. All right, what we need to keep in mind is the m is the coefficient. That was one of those C words we used last chapter. And the b is the constant. That's the other C word that we used last chapter. And we'll use them again this chapter. Okay, so if we get a problem like this where we give us a slope and the y-intercept, remember slope and m are synonyms, they mean the same thing. Y-intercept and b are synonyms, they mean the same thing. All we're doing here is plugging these in to build our equation. So y equals negative 9x plus 2 would be my equation. No different in this problem. Now we're using the letter m and the letter b. Remember, this is the slope, which is the coefficient, and this is the y-intercept, all right, which is the constant. They're not giving us the setup of the problem this time, so we got to do it ourselves. All right, what I need you to remember is that the y equals is always the same. The x is always the same. You're only filling in the slope and the y-intercept. So 4.5x plus negative 10. You could also just write minus 10. Next up, we have a line that has a slope of negative 5 and passes through the origin. So this is giving us information. It's giving us the right information, just wording it a little bit differently. So slope of negative 5 means m equals negative 5. Passing through the origin, that's the coordinate 0, 0. We only want the y value, so our b is 0. So if I build that out into an equation, remember the y equals and the x are always there. I'm only filling in the m and the b. In this case, the m is negative 5. The b is 0. I can write plus 0, but I don't have to. All right, here's a couple problems where they're giving us the equation, and we have to then interpret what is the slope, what is the y-intercept, and can we draw a quick sketch of that? So in this first one here, I realize you look at this and think, well, there's no m written there. Well, believe it or not, there's a 1. So my m equals 1. Okay, and my b here equals my constant, which is negative 5. So if I'm sketching a graph of this, what I want to make sure here is that my y-intercept is below the y-axis. Okay, negative 5. And this is an increasing graph because it has a slope of 1, and it's not too steep. Okay, so it should look something like that. Maybe not quite that. Probably a little more like this. Okay, and remember that should be looking like it's going up 1 over 1-ish, but it's just a sketch. All right, if you had a grid there, you'd be graphing that more accurately. Next up here, I have an m. But wait, there's no b value, which means it would be 0. So my m is 3, my b is 0. I need to make sure now that my landmark is the origin, and my m is 3, so it's going to be steeper. It should look steeper than the last line, okay, because 3 is a bigger number than 1. All right, so notice how this line here looks a little bit steeper than the first line. And this last sketch example, okay, now I have both numbers there. I have an m and a b, so my m is negative 5. Okay, my b is 7. So here, a couple of details about my sketch, even though it's rough, is that my b value should be above the y-axis or the x-axis because it's positive, and my slope now is -5, and that's pretty steep. Okay, it's also steep and going down. All right, so my sketch would look something like that. All right, but what happens when we try to graph these more accurately? We'll see that in problems to come. All right, let's go ahead and turn the page. Okay, here is an example that's actually on a grid. Makes a little more sense for us. So we're going to review some things that we did in previous days. We're trying to locate the m and the b, or determine the m and the b based on the picture. Okay, so if we start with slope, right, we did that. We're drawing a slope triangle. I want to find two places, two dots on that line, okay, where the line intersects the grid marks. I'm going to draw my triangle. I know some of you resisted that in class. We need to actually draw the triangle, please. I want to label the sides. So check my units. Everything's counting by ones, so I can go up 1, all right, and I can go right 3. That gives me my m, right, 1/3. Remember, it's rise over run. Okay, some of us were flip-flopping that during class the other day. My b value is where it touches the y-axis, so that'd be right there. In this case, b is going to equal 3. I can see it, so I put a 3 for b. Now I want to build that equation. Remember, my equation is always going to have the y equals x plus right? Well, what am I filling in? Y equals m x plus b, right? Is what I'm filling in. Okay, what about the next one here? All right, this one here, my first observation should be right here, right, with my y values, and seeing that they're not counting by ones. All right, that caught a few of us the other day. Still going to put two dots on the grid. All right, I'm still going to draw that slope triangle. But this time when I label it, I want to make sure I'm counting by whatever my axes are counting by. So in this case, it looks like I'm counting by 20. So 20, 40, 60. So down 60 and then right 2. All right, so just as a side note here, down 60, right 2. I want to simplify that. My slope ends up being -30. Come back up here to see my b value. Again, it's wherever it touches the y-axis. Right there, I can see it. So my b is 180. So I fill that in. Last up is writing the equation. Once I know those two pieces, I can write the equation. Remember, the y equals x plus is always there. And then I got to fill in my blanks. So -30 x plus 180. Okay, I'd like you to pause the video. All right, and I want you to do those 4 problems on your own, and then you can tune back in and see what you came up with. So there's number 6, negative slope, down 2/3. Everything's counted by 1, so I could count blocks. I can observe the y-intercept as 2, and I build out my equation, y equals -2/3 x plus 2. Number 7, not counting by 1s this time. Okay, my y-axis is counting by 3s, so even though it looks like it goes up 1, it actually goes up 3 and right 4. So my slope is 3/4. My y-intercept, I can see it right there, it's 18. Build out my equation, y equals 3/4 x plus 18. All right, number 9. All right, number 9 gives us a little bit of a curveball here, right? That's a horizontal line. Slope is 0, it's not growing. But the y-intercept still holds true, touches the y-axis of 14. So if my slope is 0 and my y-intercept is 14, I could write y equals 0x plus 14, but I don't need to do that. All right, because 0 times x would just be 0. And then last is number 10. Again, noticing here that both of my axes are counting by 2s, so I got to be careful. Even though my triangle looks like it goes up 2, right 4, it's actually up 4, right 8. That's positive slope, so 1/2 for my slope. I can see my y-intercept is at -8, so y equals 1/2 x minus 8 when I build out the equation. All right, let's finish this up here. Matt is going to create a graph of the equation 4/5 x minus 7. Mark each statement as true or false. Matt's graph will cross the y-axis at -7, That will be false. Okay, this is the y value. Okay, and this is the y-intercept. So his point would have to be 0, -7 is what Matt was thinking. He wrote the wrong thing. Matt's graph will increase from left to right. Okay, and that is true. Increase means positive slope. Okay, and my 4/5 is a positive number. Okay, circle the name of any student who wrote an equation that could possibly represent the graph shown. Now, there's no details in the graph, but what we need to notice here is that my m is positive because it's going up left to right. Okay, so left to right, it's going up. And my b is negative, okay, because it's touching below, all right, the origin. All right, so I'm looking for a positive m and a negative b. Okay, Javier has a negative m and a negative b, so it cannot be him. Carissa has a positive m and a negative b, so it could be her. Liam has a positive m and a positive b, so it cannot be Liam. So it looks like Carissa is the only one that got that correct. All right, hope you copy down your notes.